Hi, my name is Abby Hall, and I'm applying to be a chemistry ULA for next semester. I am a junior majoring in biology and minoring in history, and I am super excited about the opportunity to potentially help students taking Organic Chemistry 1 next semester. A little bit about me. I'm from Winston-Salem, North Carolina. I love watching sports, hanging out with my friends, and participating in a dance club on campus. I believe that I'm capable of helping students in this particular class because I was able to learn effective study strategies from my professors and my peers when taking Orgo 1 myself. And from these things, this helped me to receive an A in the course over this past summer when I took it with Dr. Austell. With the knowledge that I gained, I believe I would be able to successfully assist students with learning how to study better for a class as complex as organic chemistry. I can completely relate to students who are having a difficult time keeping up with the rigor of organic chemistry. During the spring of 2025, I took the class for the first time, and unfortunately, I did not end up with a passing grade. So going into summer session 1, I knew that I would have to change the way I approached the course if I wanted a different outcome. And so this is exactly what I did. I speak from personal experience when I say that it's vital to emphasize discipline and organization during the entire semester as a student taking this class. It is not a subject that you can pass by solely relying on memorization. So as a ULA, I would tell students that the key to success is to truly understand the concepts and reasoning behind why each mechanism follows the route that it does. An effective way to do this is through consistent practice with various problem types from the resources provided by the professors. If someone does this, along with making sure that they're up to date with their work and they're not falling behind, they will be successful. If I become a ULA, I will do everything to understand specifically what each student is struggling with because I recognize that everybody learns in a different way. And from there, I will offer them my best advice for how to fix the problem in a method that they can utilize throughout the entire semester. Alright, so for this synthesis problem, I think it's best to just start off by looking at the start and end products and seeing what's changed so we can see that this has gone away in the end product, this bromine, and an ether has been formed. So we can actually work retrosynthetically for this problem because we know from Williamson ether synthesis that this was an alkoxide before it became an ether. And this is a good nucleophile that we can see binds to a methyl. So we have our methyl, and then we attach it to a good leaving group, like bromine. And we can also work retrosynthetically again because we know that alkoxides form from alcohols that have been deprotonated. So this alcohol is not a good nucleophile on its own. It has to be deprotonated using a strong base, such as sodium hydride. So now we can start with our first material and move forward. We want to get rid of this bromine, and a good way to do that is by doing an E2 reaction because from this we can get rid of the bromine and we can also add an alkene. So we can use a good nucleophile and a strong base to be able to do this. And there are other examples, this is just one, but we can also emphasize that it's elimination by placing it in a heated environment. So this will get rid of the bromine and add an alkene. So now we can kind of see the similarities between the start and the end. We can tell that this carbon right here is the same as this one. And so we can tell that the alcohol was added to the less substituted carbon in the alkene in an anti-Markovnikov fashion. And we know the reaction that does this is hydroboration oxidation. So we use the associated reagents for this step to connect the two reactions. So yeah, it's totally okay to work retrosynthetically in some cases. It's just about piecing together the different reactions that you've learned to get the end result. Thank you so much for watching and for your consideration in this process.